Good day, everybody. Welcome back to SpecAc's Webinar World Series. In this month's edition, we're looking at FTIR solutions for foods and beverages. Now, there are several reasons for analysing foods and beverages using FTIR. So, for example, we want to find out the origin of the product we're consuming. The origin of the product very often corresponds to the traceability, environmental impact, and also freshness of the food. So this information is very empowering and reassuring for the consumer to help consumers make an informed, information-driven decision and to have more options. We also want to confirm the product's authenticity. Very often, a high-value product on the market is adulterated with a low-value product, which obviously is not very cost-effective for the end consumer buying the product. But more importantly, we don't want a product to be adulterated to contain any harmful substances that endanger human health. We also analyze foods and beverages for R&D reasons, so research and development reasons, because there's a need for the continuous improvement of products we consume to ensure quality, safety, healthiness of the food, cost of manufacturing, and also deliciousness of what we consume, because we like our food to taste nice, we want our drinks to taste nice. And finally, we want to ensure the quality standards are met to ensure that there are no physical, biological, or chemical contamination in our foods and beverages, and that food contact standards are met during the manufacturing process. But ultimately, all these variables contribute to the safety of foods and beverages to ensure that there are no harmful substances contained in the product that endanger human health. If there are certain substances that are allowed but can't go over a specific limit, we also want to have a solution for quantitatively and qualitatively measuring those specific limits as well. Now, food safety is not a choice, it's definitely an obligation. As you might be aware of news headlines across the globe in recent years, companies have definitely found out the hard way that the integrity and provenance of raw materials are directly linked to their reputation, and that they have a legal and public obligation to make sure that their products are safe and genuine before releasing that product onto the market. So now on this slide, we look at the challenges that those companies face from farm to fork to ensure that there are no undesired substances in the products we consume. So for example, in the first stage of the farm to fork process, you have the farm that produces meat or dairy products, fruits and vegetables and so on. And potentially there could be undesired substances like pesticides, herbicides, drug residuals and microbial strains or toxins, for example. And then as we move on to the production, processing and packaging stage, you could potentially pick up undesired substances from contacts with impellers or filters that are contaminated with microplastics. You can pick up those substances from pipes, pumps, dispensers, seals and lubricants, or even burnt substances from overcooking. We need to also make sure that all surfaces are clean, but also all food contact materials or FCM regulations are met to prevent any sort of physical, biological or chemical contamination in your product. So physical contamination would be something like bits of wood or plastic or bird feces that have accidentally fallen into your packaging reel or your food and beverage product. Biological contamination would be something like the growth of bacteria. Chemical contamination would be something like a cleaning agent accidentally contaminating your product. At times, there could also be religious considerations as well. For example, if you're making or manufacturing a product specifically for the halal market or the kosher market, we have to ensure that certain products aren't used in the manufacturing process. Halal, for example, we have to ensure that pork, lard, and pork products aren't in your final product. And this is where analytical techniques are required to ensure that. And then as we move on to putting foods and beverages onto the shelves of supermarkets, shops, storage and distribution channels, for example, we have to ensure that the food has not gone off due to the malfunction of fridges and freezers because of uncontrolled temperature and humidity, or overexposure of the product to light and air, causing gradual chemical changes. And obviously at home and in restaurants, we have to ensure that hygiene standards are met. Now, during the transport process as well, you could potentially pick up contaminants from contact with containers that are not clean, or like the supermarket stage, if your freezer or refrigerator is malfunctional, that could also cause the food to spoil, and we don't want that. So ultimately, we think that this area highlighted in green, so the farm and the production and processing stage, would require analytical techniques such as FTIR to perform your daily R&D, so research and development, and also QC, quality check of those products. So we think our products could provide a solution at this stage of the farm to fork process in particular. The stars of the day include the PEL liquid transmission accessory and also the Quest single bounce ATR accessory. Now, if you managed to join our webinar last month in April, where we looked at the analysis of lubricant oils and fish oils using the PEL, you'd be quite familiar with this slide already. But I just want to emphasize on some of the key features, including the peak intensity. So transmission gives you higher intensity due to the use of the transmission technique rather than ATR. But also the bottom key feature there, where it says heatable option, it's worth highlighting as well that the PEL doesn't currently have a heatable option. But we do have the Quest heated puck now, which is able to heat up to 110 degrees maximum, and of course the Golden Gate that can heat up to 300 degrees maximum. And these heatable ATR solutions could be your answer to applications where the melting of the sample is necessary. Now, before we move on to real-world applications, I'd just like to have a little fun with you all. So the first person to guess what the item of food is in this image will win a pack of 10 Arrow products with the aluminium puck for the Quest ATR. So please feel free to join. The first application we're looking at involves the use of the PEL liquid transmission accessory for the analysis of extra virgin olive oil, or EVOO for short. EVOO is very often considered to be one of the highest grades of oils used in cooking or garnishing. Some industries even use it for pharmaceutical purposes or for soaps and cosmetics. So there's a big market for EVOO, with the market size worth more than $70 million at the time of writing this application note. And the PEL liquid transmission accessory provides a rapid solution for the identification of adulterants used in EVOO. For example, a lower value sunflower oil or peanut oil. In figure 1 here is a set of spectra of sunflower oil versus EVOO collected with a 50 micron calcium fluoride oyster cell set in the PEL. And as you can see, Both spectra are very similar, but there's certain fatty acid related peaks where the ratios are different. Here in figure 2, you can zoom into the region at 1120 wave numbers to look at the concentration of the sunflower oil dopant concentration. And that FTIR data on the left-hand side can be converted into the calibration curve on the right-hand side in figure 3, where this calibration curve can be used continuously for future proving of the concentration of the sunflower oil dopant in future analyses. In this particular application, we look at measuring the fat content in chocolate. So the pearl, at the moment, as I've mentioned before, hasn't got a heatable option just yet. So for this application, we've had to melt the chocolate using a separate heating stage. And once the chocolate is melted, we only need to apply 10 microliters of the chocolate sample onto the pearl in order to obtain high quality, high resolution spectra, as you can see in the top right hand corner. We also provide the OmniCell, which is very often considered the conventional liquid cell or entry level liquid cell for transmission analysis of liquids. However, Omnis, they tend to be used for the analysis of not so viscous liquids, whereas for the pearl, it's more capable of analysing viscous and non-viscous liquids. In this particular application, we looked at the liquid analysis of food flavouring, so an ester used as a food additive. You see the reaction scheme in figure 1, where it's a very sort of basic nucleophilic substitution reaction of the butanol reacting with the acetic acid, and the acetic acid is then converted into an ester, which is sort of a scent that you smell from red apples and various good smelling foods like pears and so on. And in figure 2, you see a series of FTIR spectra of the different components in that reaction scheme. So you've got the reactants and the product. And in table 1, you also see the peaks of the major functional groups associated with those reactants and the product. So now we've just finished talking about using the pearl accessory for liquid transmission analyses. We'll now move on to the Quest, used for single bounce ATR analyses. So the Quest family has expanded with the addition of the heated puck product, which is able to heat up to 110 degrees C, which would be particularly useful for something like the chocolate application you saw a few slides ago. So instead of heating the chocolate separately on a heating plate outside the pearl accessory, you can now use the heated puck to heat up your chocolate and analyze at the same time. And same with anything that is water-based and can melt from a solid to a liquid. We've also got the Arrow product, which is a consumable ATR product, the first of its kind, added to the Quest family as well. So in the next few slides, we'll be looking at some of the applications related to the heated puck and the Arrow. Let's go through some of the key features and benefits of the Quest Quest heated puck. We believe these key features stand out from competition due to a range of reasons. Reason number one, it can be used to heat up solids and liquids up to 110 degrees Celsius and is suitable for edible oils, trans fats, proteins, and also acid soap-based transition applications. It uses a high precision 4-wire platinum RTD sensor, enabling accurate and stable temperature control. It uses an adhesive-free, non-laminated monolithic diamond, enabling excellent thermal and chemical robustness, and also a full spectral range is enabled by using this monolithic diamond rather than a composite material. It uses a PC software and USB controller to save lab space, and also allows real-time monitoring of temperature curves, automation, and easy data logging. And it's compatible with all Quest ATRs, just plug and play. With this widest range of sample pucks, we believe that the Quest remains the most future-proof and versatile ATR in the world.
The heated puck adapts any Quest family ATR accessory for experiments up to 110 degrees C. Easy sample loading. The butter emulsion melts into two phases, with the water phase on the bottom. As the temperature increases, the water evaporates, concentrating the dissolved milk solids, which are left as a residue beneath the fat layer. After your experiment is over, simply wipe away and clean with a suitable solvent.
The quantification of foods and beverages is particularly important for the compliance of local regulations, labelling, and also the application of customs duties when imported. In this particular application, we look at using the Quest consumable Arrow ATR product for the chemometric quantification of ethanol in alcoholic beverages, like wine, for example. Now, this application is not limited to using the Arrow consumable ATR product. You may also choose to use the diamond puck, for example. Conventionally comes with the Quest ATR. You can choose to use the multi-bounce gateway, for example, or even the liquid transmission accessories like the Pearl and the Omni cell we touched upon in a few slides ago. But we want to just re-emphasize the key value proposition of the Arrow and reintroduce the Arrow to you all. So in this particular application, we decided to use the Arrow, which usually is ideal for high volume batch analyses, zero cross-contamination, difficult applications like corrosives or sticky substances, no cleaning in between runs, and also a concurrent workflow, as you can see in the graph in the middle there, where a lot of time is saved when you're analyzing a high volume of samples when compared to more sort of traditional ATR puck. This slide just emphasizes how the Arrow is suitable for chemometric analysis. So we collected some spectra of ethanol and water, and then from that we constructed a model. On the bottom left-hand corner, you see that factor 1 is very good at separating 100% concentration from a mixture of different concentrations. And then factor 2 is used to distinguish between the different concentrations from 0% to 5, 10, 20%, and 40%, for example. And then we collected more spectra to then plot a graph of the predicted model against known concentration of the alcohol, which showed very strong correlation. Another use of the Quest arrow would be the detection of adulterants in food products like syrup. In the world of syrup, maple syrup is considered to be the highest grade of syrups, and you can see in the red spectrum there, it's got a very distinctive set of peaks from 1100 to 900 wave numbers. I like to call it the camel humps, which is very characteristic of maple syrup. Very often manufacturers could adulterate the higher value maple syrup with a lower value syrup like cane or rice syrup as seen in the black spectrum. And so the arrow or other spec accessories like the diamond puck or pearl, for example, could be used for the analysis and authentication and fraud detection of different product types like syrup or honey or milk or olive oil, as we've touched upon already. In this particular application, we're not looking at food specifically, we're actually looking at the packaging, which is relevant to food in a lot of ways because we need the packaging to wrap around the food to ensure we prolong the shelf life of the product. And very often in flexible packaging, a solvent-free adhesive is used to stick different pieces of polymers together to produce a multi-layered packaging. But we have to ensure that the glue or the adhesive is cured properly, as you can see in the reaction scheme, where if it isn't, the isocyanate reactant could potentially migrate into the food product and react with the moistures in the food and beverage product to give an aromatic amine, which is deemed to be carcinogenic. So in this particular application, again, we're looking at using the arrow to monitor the decay rates of the isocyanates. And in the next animation, you can see that the arrow could be used to measure the isocyanate decay rates against time, and that curing time can take up to days or even weeks, and this is why the arrow is ideal for this sort of application. And in the next animation, you can see here that even multiple arrow slides could be used to monitor different variables that determine the curing rate of the isocyanate. So for example, the isocyanate to polyol ratio, or the temperature in the environment, or humidity in the environment, or how much coating weight you've applied to the packaging as well. And you can monitor all that simultaneously by using a lot of arrow slides. So the arrow is perfect for irreversible reactions. There is no sample preparation compared to conventional methods where in the packaging industry they use hand lamination or maybe a semi-industrial laminator or full-on industrial laminator, which is very time consuming for doing this sort of FTIR analysis if you just want to have a quick screening test. There's absolutely no need to clean in between runs, and you can monitor multiple samples in a very inexpensive way. This is also linked to the slide you saw previously, where you can see that the adhesive initially is in a liquid form, but eventually it cures into an irreversibly hardened thermoset. And once this thermoset is set on your crystal, in this case it's actually a silicon wafer in the Arrow product, it's going to be very hard to remove that thermoset from your silicon wafer or your ATR element. So the question you want to ask here is that, would you rather risk your less expensive product in the consumable Arrow, or do you want that to be sticking onto your more expensive ATR crystal? Are you able to have a lot of different diamond ATR pucks for this sort of experiment? Or would the Arrow be more suitable for this sort of experiment? So those are some of the questions you should ask the customers when choosing the right product. So as mentioned before, the Arrow is perfect for prolonged reaction times, for example, where the chemical curing of the isocyanate can take days or weeks. So when you look at the thermoset, by appearance to the naked eye, even though you see a solid product, within that thermoset, it's very possible that chemically the isocyanate is not cured completely. And so it needs to be left for days or even weeks for it to cure completely during that time. And, could you possibly do the same experiment using a diamond ATR and leave it idle for 2 weeks or more, or even months, for example? So this is where the Arrow is ideal. It frees up your standard ATR equipment. You can do multiple analyses using multiple Arrow slides, and you also eliminate the risk of damaging your more expensive ATR crystal when trying to remove difficult substances. Now, did you know that the 4 most adulterated foods by research are olive oil, alcohol, milk powder, and meat? So I found that to be quite interesting. So now, in terms of SpecX solutions for food and beverage analysis, we believe we have a range of products that provide you with the efficiency, data quality, robustness, and user-friendliness to perform the analyses of food and beverage products. Our products are not just limited to foods and beverages. It can also be rolled out to the pharmaceutical industry, for example. Continuing from that, we now have some case studies involving the Surveyor microscope and also our diamond compression cells. In this particular application, there is this pharmaceutical tablet received with the contamination, as you can see with the little spots there on the red pill. Of course, it's not so clear, so by the use of a microscope, we can magnify into the contaminant, which is roughly 200 microns, as recorded through the diamond ATR using oblique illumination. And the resulting spectra, as you can see on the right-hand side on figure 3A and figure 3B. In blue, you have the contaminant, which is some sort of ethylene or propylene copolymer, typically used for gaskets in the manufacturing process. And in figure 3B, the red spectrum, you have the tablet coating, which is believed to be HPMC coating. By using this technique, because it's an ATR method, you're able to analyze the first few microns of the coating without penetrating into the pill to analyze the active ingredients of the pill. So you're merely just analyzing the outer surface of the pill. And here is a similar application, case study number 2, looking at food additive crystal contamination. And the food additive in question here is citric acid, which is very often used as a flavoring agent or food preservative. And when you put it under the microscope, it becomes more clear that the citric acid crystals are off color, so it's become discolorated. It's now got a different texture to it, as highlighted by oblique illumination on the severe microscope. And the resulting spectra, as you can see on the right-hand side, you have the citric acid plus the contaminant in figure 3a, the red spectrum. And then at the bottom, figure 3b, you have a blue spectrum highlighting the contaminant as being hydraulic fluid. And the cause of this hydraulic fluid in the citric acid product is apparently a compromise of the seal in one of the pumps, resulting in contamination of the food additive product. So in terms of FTI accessories, obviously today we've covered the Quest range, which is a single bounce ATR accessory, the Pearl liquid transmission accessory. We've not managed to talk about the Gateway multi-bounce ATR. There's also a very good product for your toolbox, especially if you want a higher intensity of peaks compared to single bounce ATR. And these are deemed to be ex situ analysis at times, because what I mean here is that instead of analysing your product in the pipework of an industrial plant, very often you're extracting small samples from the manufacturing plant for testing in a QC room separate to the manufacturing plant, where you normally place your FTIR spectrometer. So this is what I mean by ex situ analysis. But if you want something more online and in situ, one of our key products as well is the fiber optic coupled near IR process cells for this sort of real-time monitoring in the liquid manufacturing or industrial environment. As mentioned before, we also provide cost-effective FTIR microscopes for the identification and subsequent removal of contaminants from food, beverages, or packaging. If you're interested in any of our products or applications, please feel free to contact us. We'll be more than happy to discuss these with you on a one-to-one basis. Now, the big reveal of what the item in question is, as we saw at the beginning of the webinar, is actually a cake, not a hamburger. And so I think the lesson here is that very often items you buy or items you see is not what you think it is. So it's very important to put it under the microscope or a spec accessory, so to speak. We've completed the webinar on the solutions for foods and beverages, and the link will be available in this month's newsletter. Last month, of course, we talked about using the Pearl for the analysis of lubricant oil and fish oil. The link is still available in last month's newsletter. If you need a copy of the link or the webinar, feel free to contact us as well. And hopefully we'll see you in next month's webinar, where we'll be looking at the analysis of polymers using ATR and transmission products. Currently, it's scheduled for the 8th of June 2022. So that's it. Thank you for listening. And if you have any questions, please feel free to write them down in the comment section. And myself and my colleagues and our experts will answer you in due course. Thank you very much again.